Okay, so welcome back. We're going to take a hopefully quick look at using electrolysis for separating ions. So when you have a solution containing a mixture of ions, we've seen that there's different ways that you can separate those ions. We had those slightly soluble types of problems, and here's another one that we can use to utilize. So when you have a solution containing a mixture of ions, you can run a current through the solution starting with a low voltage and increasing it steadily. And the element with the largest positive potential will plate out first. So let's go ahead and make sure that we stress that largest positive is going to plate out first. And sometimes they may try and trip you up by referring to oxidizing ability. Well, oxidizing ability refers to the ability of the substance to take electrons from a source, so the higher cell potential value, the more oxidizing ability for the half reaction. In other words, same idea. Largest positive cell potential. So if we're comparing these two, right, double X or double Y, it would appear that double Y should be able to plate out first, should have a greater oxidizing ability. Alright, so as it says here, because double Y has a larger standard cell potential, when double Y is in solution with double X and the voltage is increased gradually from a very small value, it's going to be the ion of double Y that's going to turn into its non-ion or elemental form first. So typically this can be interpreted as less reactive elements will plate out first. So if you have a sense of things like, hey, sodium's pretty reactive, but I know copper's not, copper's going to be the one that plates out. Copper's got the better oxidizing ability. So let's take a look here at a couple of example problems. And so we've got our iron 2 versus aluminum example to look at. And so when it comes to iron 2 plus, standard cell potential associated with iron 2 plus going to a solid is negative 0.44 volts, and with aluminum 3 plus going to a solid, the cell potential there is going to be a negative 1.66 volts. So let's make this clear just so everybody understands. What I've looked up is this half reaction for iron and this half reaction for aluminum. And so really what I'm focused on is these two values here. And with the iron 2 plus being more positive, it should be the one that plates out first. And so it should be that iron plates first. So that's pretty much that. It's just a straight comparison of these two. More positive plates first. Negative 0.44 is more positive than negative 1.66. So the next thing I have here is this. If a solution contains cobalt ions and silver ions, which metal ion has the most oxidizing ability, and which metal is likely to be plated out onto the cathode if a very low voltage is gradually increased? So ignore practice problem 95. This is not practice problem 95, but it's pretty similar to it. Again, taking a look here, so CO2 plus 2 electrons goes to cobalt solid versus silver plus 1 electron goes to silver solid. Have a standard potential for these two of, in the case of cobalt, negative 0.28 volts. In the case of silver, I've got 0.80 volts. So again, greater oxidizing ability is going to be determined by comparing the two standard cell potentials, and it would appear that with silver having a more positive cell potential, silver should have more oxidizing ability, which also means that silver should plate first. That word is first. So yeah, It's pretty much the comparison that you're going to be making for oxidizing ability and plating out. The two relate. So as soon as you've decided one, you've decided the other automatically, and it comes from a comparison of those standard cell potentials. So I hope this helps. Good luck putting it to use for yourselves.